Alright, so welcome to Unit 2, which is what we start to consider real calculus. It's not so much review in this particular chapter. We're going to start talking about rates of change and limits. So, limits are basically what separates calculus from pre-calculus, even though, yes, we did talk about limits slightly in pre-calculus. We're going to go much more in-depth in this class. Using a limit is also the foundational principle behind two of the most important concepts in calculus, which I have said. We're going to be talking about something called derivatives and integrals this year. Limits can be used using substitution, graphing, numerical approximation, algebra, or some different combination of these. So way back in the day in pre-calc, we used the formula d is equal to rt to determine what the heck the speed of an object is. And what we found was the object's average speed, and that's all we found. And then a body's average speed during the interval time is found by dividing the two total distances covered by the elapsed time. So speed is always positive, velocity indicates a direction which can be negative, and we are going to find the average velocity. If an object is dropped from initial height, which is h of 0, or h sub 0, we can use the position function represented by s of t is equal to negative 16 t squared plus h sub 0 to model the height s in feet of an object that has fallen t seconds. Alright, so that was a lot. So, basically, we're talking about something called average velocity. Distance was rate times time. Using this formula, I can figure out, hey, that rate is just distance over time. In summary, other summary that I have said, if I have positive velocity, that indicates that I have positive direction. Likewise, if I have negative velocity, I have negative direction. Alright, other stuff that I have said is that basically speed is always positive. How I can guarantee that is I can say, okay, speed, just gonna erase that. So speed is always positive, so I can say that by saying speed is just going to be equal to the absolute value of velocity. That way I can indicate, hey, velocity is always positive. Surprise! Alright, the key thing about speed is that it does not indicate a direction. Even though it does involve velocity, since it is always positive, it is not going to say, hey, it's always going to be moving in a positive direction. That's the only thing that is unfortunate. Alright, so that is in summary. So let's look at an example 1. It says Wile E. Coyote is once again trying to catch that roadrunner and waits for the nastily speedy bird atop of a 900-foot cliff with his rocket pack strapped to his back. Wiley is posed to leap from a cliff and just fires up his rocket pack and finally is going to partake in the juicy roadrunner roast. Seconds later, the roadrunner zips by and Wiley leaps from the cliff. Alas, as always, the rocket malfunctions to fire, sending Wiley plummeting to the ground below and disappearing in a cloud of dust. If you've not seen the Roadrunner, what ends up happening is basically Wile E. Coyote is always, the losing party, like it is in cartoons. He will run off of a cliff and he pauses in the air for a second only to go plummeting down, which is kind of sad for him, but, it's fine. It's a cartoon. So, initially, I want to know, what is the position for Wile E. Coyote? Well, position, we're just going to be using this fun little function. So, what was my initial height? Well, my initial height, it says that I'm atop that 900-foot cliff, so that's going to be my h of 0, or h sub 0. So I'd have s of, I guess, t in this case, because we don't really know what exactly my time is yet. S of t should be equal to negative 16 t squared plus h of 0, which we just said was 900. And that's it for that one. Alright, finding Wile E's average velocity for the first 3 seconds. So I'm going to take his position over those first 3 seconds and divide by how much time there is. This way I get their average position over the time it takes. So average position, I'm going to be using that position function. So I know in the end I've got s of 3, and I started with s of 0. Over the amount of time, well, I'm going to end at 3 seconds, but I began at 0 seconds in this particular case. Alright, so all this tells me is go into that original function, plug in 3 in for t to that equation up above, and then also plug in 0, subtracting those two answers from each other. I should get negative 144. And then 3 minus 0, easy enough, should give me 3. So again, how I got that 144, oops, I erased my 16. I got my s of 3 is equal to that negative 16 times 3 squared plus 900. And I got the s of 0 is equal to negative 16 times 0 squared. Oops, that should be a squared as well. Plus 900. And then I took those two answers and I subtracted them up top, which is how I got that negative 144. Alright, dividing that by 3, I should get negative 48. Alright, so negative 48 actually does make sense in this case because, again, he is starting at positive 900 feet and he is falling and plummeting straight down. Well, since he's falling straight down, he is falling at a foot, or feet in this case, per rereading feet per second. Okay. Alright, glad I had to reread that. Alright, and that's all that we're doing on this. Alright, so a couple of notes. If you really wanted to, instead, you could just graph this function because average velocity is always going to be the slope between 2 points on the position function. Because, fun fact, that just is like a y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. That's all that is. Fun fact. Rate of change. Okay, next one. We need to find Wiley's average velocity between t is equal to 2 and t is equal to 3. So again, same type of deal. Y sub 2, which would be s of 3 in this case, minus y sub 1, which would be s of 2 in this case, all over 3 minus 2. Alright, so this is all going to be over 1. I get to go type this fun mess into a calculator again, and so can you. Alright, typing that all in. Really, this time I should already have that s of 3 answer. Type in s of 2. Subtract s of 3's answer from s of 2's. Should get 80. So again, I've got, this is going to be equal to negative 80 feet per second. And again, that makes sense because he is falling. That is in a negative direction. If we were gaining, we would be going up. Alright, next one says find Wiley's velocity at an instant at t is equal to 3. Well, crap. Now if I try to do s of 3 minus s of 3 all over 3 minus 3, I get 0 divided by 0. And that's an issue because that's what we call undefined, or we have up until this moment. So this is where something called limits come into play. Fun times.